Hi everyone, and welcome back to Calculating Building Peak Loads. We are now going to dive into running our train trace simulation and looking at calculation methods in trace. Save sort of the best one for the last here. I guess actually probably in the middle. This is, where are we? We are at number 6 in our 10-part series. A lot of these have turned into 2 videos, but that's the nature of how it goes. So, without further ado, let's run to trace. So we have our trace model here, and we are about to hit calculate and look at some of our loads. And to do that, you can click this calculation button here. It's also at the top of your window. And here's our model. It's about ready to run. We have one alternative. It's possible to have up to 4. Generally you have only 1. We could hit calculate. Before we hit calculate, it's very important to check the load parameters on the right hand side. So under load parameters, in here it will limit a number of different things. We can limit the months that it will actually search for the peak, and right now it actually has 1 day per month. That's how trace works, is it has one 24-hour period for each month. And we could also limit the exact hour. There are reasons you might do this. For example, if you ran the model once and you knew that the building peaked at September the 5th, or September at a certain time at 5 o'clock, 5 o'clock would be 1700, you could actually say, actually I only want to run the model at September at 5 o'clock. And that way all my results will all be at that 1 hour, and now I will know what each room contributed to the overall building's peak, because I've forced trace to only give me answers in this very, very limited window. When you expand the window to normal operations, it's now hunting for the peaks. So if a room is facing west, it will peak in the late afternoon. If it's facing east, it will peak in the morning, and you'll see those differences on the output reports. So that's this whole idea of the different days and times of the year and months of the year. In this loads parameter as well, you can also rotate the entire building. This can be very useful if you are making your building, doing hand takeoffs or measurement takeoffs or whatever it is, and you know that the entire site is rotated 30 degrees from north or 25 degrees from south, whatever it is. You could come in here and you could rotate the entire building. It's also useful if you forgot to rotate your walls and later found the building is slightly off. Instead of fixing every single wall's orientation, you can change it here. On the right hand side, we have airflow units. I usually leave everything as standard. The biggest one is methodologies, cooling and heating methodologies. We would like to use, most of the time for cooling loads, the radiant time series method, and I like to use the radiant time series heat balance method. There are several other peak cooling methods, some of them older than others. Different ones say ASHRAE in them. One says CEC DOE 2. So for example, CEC DOE 2 is running the DOE 2 engine that the California Energy Commission helped develop part of that. They didn't make the whole thing. But each one of these was sort of developed by a different group. A lot of them developed by ASHRAE, and they were all developed over the years. Some are used for residential, some are used for different calculation accuracy types. The heat balance method is the most up-to-date out of all of these. The major difference that's going to change in all of these is how the solar radiation is translated through the building's envelope and into the mass of the building. That's the number one major differences between the cooling load time dependent value method, CLTD, cooling load time, yes, and RTS, radiant time series. We could spend a whole other video, and we probably will, on radiant time series. But for now, always choose RTS heat balance, and for heating, always choose CLTD ASHRAE. You can also change the infiltration, the outside air film, whether you're in a city A lot of this is just going to change, add a little bit of a different wind effect and convective effect on the outside of your building. I usually don't change those. You can if you would like, but for now, mostly just pick those two. So there we go. Now we're ready. I'm going to hit calculate, and if we're lucky, we'll be able to see it as it runs. Ran very quickly, and you can't see anything. So that's too bad. But you can see it step through each month, the one day of each month, if your building is big enough. So that is running Trane Trace and setting the methodologies. Always set those methodologies. It's very, very important. Those are the heart of the tool that we are using. All right, let's move on to looking at the reports and